In this video, let us try to prove these two questions. So in the first one, we have a long equation, but however, it is just a simple application of formula SinC plus SinD as well as CosC plus CosD in the denominator and numerator respectively. Let's try the first one now. So in the first one, what we'll do is we will group two terms so that we can apply the formula of CosC plus CosD and SinC plus SinD and SinC minus SinD. So let's apply CosC plus CosD in the numerator, which is CosC plus CosD will be equal to 2 cos C plus D by 2 times cos of C minus D by 2. And the another formula we are going to use is sin C plus sin D, which is 2 sin C plus D by 2 and cos of C minus D by 2. The last formula we are going to use is sin C minus sin D, which is 2 cos C plus D by 2 and sin of C minus D by 2. So let's apply that in the numerator. So it's just a careful application, so it should not be complex. Let's do that now. So for the first part, we would have 2 cos of A plus B plus C minus A plus B plus C, this divided by 2 times cos of A plus B plus C plus A minus B minus C by 2. Now I'm applying it to the second part, this part. So that will be plus 2 cos A minus B plus C plus A plus B minus C, this thing divided by 2, multiplied by cos of, I'm going to write it in the second line now, multiplied by cos of A minus B plus C minus A minus B plus C, this divided by 2. So now numerator is completed. So the denominator would be, let's apply sin C plus sin D now first. That would be 2 times, okay, I can see the denominator now, 2 times sin of A plus B plus C minus A plus B plus C, this divided by 2 times cos of A plus B plus C plus A minus B minus C, this divided by 2. So the last part pending is this one now. I'm going to apply sin C minus sin D. So this will be plus 2 sin, I'll apply 2 cos C plus D by 2. So let me do that, 2 times cos of A minus B plus C plus A plus B minus plus A plus B minus C, correct, divided by 2, multiplied by sin of C minus D by 2. That would be A minus B plus C minus A minus B plus C divided by 2. Okay. Now that we have carefully applied the formula, let's try to see what we can cancel out here. So in the first term, we can cancel out A, and in the second term, we can cancel out B and C. In the third term, we can cancel out B and C. And in the last term of the numerator, we can cancel out A. Okay. Now in the denominator, what can we cancel out here? We can cancel out A, and here we can cancel out B and C. In the third term, we can cancel out C and B, and in the last term of the denominator, we can cancel out A. Okay, so now if you notice here, there are two B's, which is this one and this one. So 2B plus 2C by 2. So we can cancel out 2 also. So all these 2's will get cancelled. So the numerator, first variable will be cos of B plus C multiplied by cos of, here it is 2A by 2. So it is cos A, plus second term is cos of 2A by 2. So cos A multiplied by, last term of the numerator is minus 2B plus 2C. So this will be cos of minus B plus C. Okay, so the numerator is completed now. Now let's look at the denominator. So the first term will have sine of 2B plus 2C divided by 2. So we can write it as sine of B plus C multiplied by second term is cos of 2A divided by 2. So that will be cos A, plus then next term also will be equal to cos of 2A divided by 2. So that will be cos A. Then the last value would be sine of minus 2B plus 2C by 2. So this will be minus B plus C by 2B minus 2B plus 2C by 2. So we can cancel that out. So we'll have sine of minus B plus C by 2. Okay, now how can we simplify this further? Okay, we can cancel out all the cos A values because it exists in all the 4 terms. So let's rewrite this as cos of B plus C plus cos of minus B plus C divided by sine of B plus C plus sine of minus B plus C. Okay. Now again we can apply the formula of cos C plus cos D divided by sin C plus sin D. So that will be 2 cos of B plus C minus B plus C by 2 times cos of B plus C plus B minus C by 2. This whole thing divided by, now we are going to apply sin C plus sin D. That will be 2 sin C plus D by 2. So it will be B plus C minus B plus C by 2 and cos C minus D by 2. So that will be B plus C plus B minus C, this divided by 2. Now what can we cancel out here? We can cancel out the 2, then we can cancel out B in the first part, we can cancel out C in the second part here, then in the denominator we can cancel out B, and then we can cancel out C. So this will change to cos of 2C by 2 cos C multiplied by cos of 2B by 2 cos B divided by sine of 2C by 2, which is sin C, and cos of 2B by 2, which is cos B. Okay, we can cancel out cos B. So our final answer will be cotangent of C or cot C. So this is how we can solve question number 1. So it is just a repeated application of formula related to converting sum of trigonometric function to product of trigonometric functions. So if you are very well versed with these formulas, then solving these questions would be very easy for you. Please practice these problems again. It does not matter if you repeatedly practice one question, your skill to solve these questions will improve. There is nothing wrong in practicing one question multiple times. Thank you so much for watching. Now let's try the second one. In the second question, we have to prove that this equation is equal to 0. Here, if you notice, these groupings are of format sin A cos B, but we have a formula which is 2 sin A cos B, which is sine of A plus B plus sine of A minus B. So let us multiply this entire equation with 2. So our question can be rewritten as 2 sine of B minus C times cos of A minus D plus 2 sine of C minus A times cos of B minus D plus 2 sine of A minus B times cos of C minus D. Now let's apply the formula of 2 sin A cos B, which is sine of A plus B plus sine of A minus B. So that will be, so the first part, so that it's easy, let me change the color. So the first part will be sine of A plus B, which is B minus C plus A minus D plus sine of A minus B will be B minus C minus A plus D. Now I'm going to solve the second part now. This will be plus sine of A plus B again, which is C minus A plus B minus D. Then A minus B would be plus plus sine of A minus B is sine of C minus A minus B plus D. Now the last part is plus sine of A minus B plus C minus D plus sine of A minus B would be A minus B minus C plus D. Okay, now we have to rearrange the values so that there is a cancellation between all these terms. Let's see what we can do here. Let me change the color. So in the first term, what I'll do this is sine of minus 1 times C plus D minus B minus A. So that will be my first term. Then second term would be sine of minus 1 times C plus A minus B minus D. Now the second term, now the third term, what I'll do is plus sine of minus 1 times A plus D minus C minus B. And now let me see if, so I already have negative values of these three terms. So I'll retain all the other terms the same way. So this will be plus sine of C minus A minus B plus D, and the last two terms will be plus sine of A minus B plus C minus D plus sine of A minus B minus C plus D. Okay, now let's see if we can cancel out any of these terms. So the first term here has C plus D minus B minus A. That means minus value of B and minus value of A. So let's see if there is any variable which has minus A and minus B. So we found that here. So basically sine of minus x is minus sine x. So this is this will be sine of minus x is equal to minus sine x. So we can cancel out this term and this term. Now in the second term, we have minus b and minus d. So we have minus b and minus d here. So this is again sine of minus x is minus sine x. So we can cancel out this term and this term. Now the last set we have is minus b and minus c. So we find that here minus b minus c, minus b minus c. So this is again sine of minus x is minus sine x. So all the 6 terms get cancelled out with each other, and the value we will have is 0. So this is how we can apply product to sum formula and arrive at the proof. Please practice this problem again so that you are well versed with the formula application. And please share this video with your friends. Thank you so much for watching. I'll see you in the next video.